you say that the grades are
Okay.
higher?
I'd say your paper was probably good.
When are we going to
All right. We gotta look at all of our tests. I don't know. When is everybody gonna have them taken? That's the next question. We gotta get people here, we gotta get people taking them, but the good news is we are ready to start number 4. We're still in 5.1, but number 4, part B. And we are solving equations. Okay? So we started this the other day, and we gotta pay attention to our directions. What did we say this meant? What does that tell me? That tells me my domain, but it's listed in radians. So when I get around to answering the question, it's going to be in radians, isn't it? Okay. So now, Ellie, are you coming from Cunningham or something? Is that why you're right? Okay, so now, let's see if we can solve this equation. Okay? Thoughts?
square root?
Yeah, absolutely. We're going to square root both sides. That's what we do. So the tangent equals, what do I have to remember over here? Plus or minus the square root of 3. I have to remember that plus or minus, right? Now, what that tells me is my tangent can be positive or negative. Well, doesn't that mean it could be anywhere? So it could be in quadrant 1, 2, 3, or 4. So we've got the whole butterfly bow tie going. And the tangent is root 3 over 1. Which makes that angle how big? 60. Now, I am supposed to be in radians, so I can find all my degree answers and then change them all at once, and then change them all. Or I think what I'm going to do is go ahead and change this. 60 is how many radians? It's 1/3 of a pi, right? So it's pi over 3. So that means all of these are pi over 3s. Remember, you only need to solve one triangle. They're all exactly the same. So my answers are going to be my purple angle, which is pi over 3. And then my red angle, which would be pi minus pi over 3. Would you agree with that? So that's 2 pi over 3, right? And then my green angle, which will be pi plus pi over 3. 4 pi over 3, yep. 4/3 pi, same thing. And then I'll just do it black. My big black angle, which is 2 pi minus pi over 3, or 5 pi over 3. So there are your 4 answers to that problem. All 4 of them, yep. Because we're plus or minus makes it everywhere. All right, what about C? What's your thought on solving this thing? Take a look at it carefully. What do you think you might want to do?
Get the sign on the same side.
Yeah, we need to get the sign moved over. That's exactly right. Yep, so we're going to get it set equal to 0. Perfect. And that way we can factor out a sign. Do you remember doing that the other day? It seems like forever ago, but do you remember getting everything on the same side so that you could factor out your sine. So we're gonna factor that out, and that's gonna leave us with tangent squared minus 1. And then what do? Once we've taken our sine out, we've factored out our common factor, remember to put the 1 there, then what do I do now? Set them equal to 0, sure. So sine x equals 0, and tangent squared equals 1. Oh, this is gonna have a bunch of answers. All right, so here we go. Those zeros, remember, tell me I have to look at my circle, agreed? Remember that? So I'm looking around the circle, and I'm looking for places where y is 0, because y is the sign. So where is y 0? 0 and pi? Remember, I'm in radians. So I'm going to say my answers so far are 0 and pi. Now, how do I solve this? We just did one just like it. Square root. So that's going to say tangent equals plus or minus 1, which again means we're going to be everywhere. So I'm going to move it over here. It's kind of out of room down there. So I'm going to move it. So I'm going to have answers in every quadrant, and the tangent is 1. So how big is that angle right there? 45, which is pi over 4. So I have pi over 4 or 45-degree angles in every quadrant, okay? So the first one is obviously pi over 4. Now the next one is going to be pi minus pi over 4. Would you all agree with that? 3/4 pi, 3 pi over 4. And then the next one, remember you start here and go all the way around, is going to be pi plus pi over 4. 5 pi over 4. And then the last one is all the way around to here, which is 2 pi minus pi over 4. And that's 7 pi over 4. So you have those two answers that we got from the first factor, and then these 4 answers. So that problem has 6 answers.
None of them are extraneous.
They are not, because if the sine is 0, so is the tangent. We run into problems. Remember, tangent is sine over cosine. So we run into problems when the cosine is 0, not when the sine is 0, if it's a tangent problem. Okay, awesome. One more, and then we're moving on to something different. Oh, actually, we're not. It's just with our calculator. All right, so here we go. One more. All right, does anybody have an idea about the next problem? Look at it carefully. It's a little bit different. Any ideas at all about what we might do with this guy?
Factor.
Yes!
Factor.
Yes, yes, factor. How does it factor? I think it'll be 2 cosine. Let's see if that works. Let's FOIL it back together. First terms, give me 4 cosine squared. Outsides and insides give me -2, so that'll add up to -4. And then I get a +1 on the end. So we're kind of lucky the factors are the same. So we really only have to solve one of them. So 2 cosine equals 1, which means cosine equals 1/2. Okay, this one is not everywhere. Which quadrants will the cosine be a positive number? 1 and 4. 1 and 4. Kids, cosine is x, cosine is x, cosine is x. Positive in 1 and 4. The cosine is 1/2. That makes this the √3, right? Which makes this how big? That's the angle we need. Pi over 3. Very good. It's 60 degrees, which is pi over 3 radians. Super. So that means this one's also pi over 3. So my two, I only have 2 answers. This one, which is pi over 3. And then what's the one all the way around to the 4th quadrant? 5 pi over 3, because it's going to be 2 pi minus pi over 3. Remember, all the way around is 2 pi. So 2 pi minus pi over 3 would give me 5 pi over 3. That is exactly right. Good job, Grace. Okay? Yes. Now we're going to do the same thing, but our angles aren't going to be special. We're going to use our calculator. So these are easy little equations. The ones I wrote down here are really easy. Use your calculator to find all the solutions. Give your answer in both degrees and radians. Okay, so both degrees and radians, that's fine. I'm using my calculator. I'll just do a mode change and it'll be easy. But here's the part that I want you to pay attention to. All solutions. All the problems we've done up to this moment, we have had a definite domain, whether it was this or in radians. And what did that mean? We were going around the circle one time, so we would have one answer in quadrant 1, one in quadrant 2, and so on. But remember, we have those things called coterminal angles. So if this red angle right here is an answer, which it is, wouldn't this purple angle also be an answer? Now, I didn't use it because it's not one time around. But now that I'm finding all the solutions, I'm going to have to keep that in mind. So, well, let's figure out, first of all, where are our answers? What quadrants? It's a cosine and it's positive.
1 and 4.
So 1 and 4. Yep, 1 and 4. All right, so I'm going to go to my calculator and I'm going to find this angle right here. I'm going to find the angle, whose cosine is 0.37. Remember, to find an angle, you do second cosine. Now, do you want to do degrees first or radians first? It doesn't matter. Degrees? All right, so I'm going to have to set my calculator in degree mode. And then I'm going to type second cosine 0.37. And this angle is 68.28. Which means so is this one, right? So the first time around, my answers are going to be 68.28. And what's the other one going to be? What's this angle going to be? 360 minus that. So 291.72. So right now we're in degrees. We're going to do it in radians in a minute, but right now we're in degrees. And those are the answers in the first revolution. But we need all the answers. So that means we need all of the coterminal angles. How do we find coterminal angles? We add and subtract a revolution. And since we're in degrees, that means that we will add and subtract 360s. So we're adding and subtracting multiples of 360. It is a whole number, so we're adding no 360s, 1 360, 2 360s, 3 360s, and so on. So there are all of the answers in degrees, okay? This is whole numbers, that's 0, 1, 2, 3. We're adding those multiples of 360, or subtracting. So that's going to give me every positive and negative angle that could possibly answer that equation. Now, I'm going to do the same thing in radians. Obviously, the answer is going to look different. So I'm just going to set my, you can do this a couple different ways. I'm just going to go ahead and retype it in to set my calculator in radians and do second cosine 0.37. And now I get 1.19 for my first answer. Now, how will I get my second answer, the one all the way around? I won't subtract it from 360, I'll subtract it from 2 pi. And I get 5.09. So there are the two answers to the problem in radians. Now, to get all of the answers, I will add and subtract revolutions again. But the revolutions aren't 360s, the revolutions are 2 pi's. So 2 pi n. So I'm adding and subtracting multiples of 2 pi n. Or 2 pi, multiples of 2 pi. So 1 2 pi, 2 2 pi's, 3 3 pi's, and so on. And there they are, all of the answers. Would you try 6 on your own? See if you can make any headway with problem number 6. You're doing exactly the same thing. Your triangles will be in a different place now because this is a tangent problem. But you're going to do exactly the same thing. And while you're working on that, I'm going to hand out some stuff. I think it's probably stapled to something that I gave you.
I'll check it.
But I'll see if I have another one. I don't know if I do or not. I didn't mark that one.
Oh, yeah, I was a little late. I went to the restroom. My bad.
All right, did I give everybody one of these? These are some extra practice review things. Everybody got one? Okay. What kind of progress are you making on your tangent problem?
Almost done.
Don't lose this, Solar. You don't get any more. Okay, where did you put your angles? 1 and 3, perfect. Kids, that's step 1. You gotta get your angles in the right spot. So then, did you find your reference angle? That's this angle right here, the little triangle angle. I'll do it in degrees since we did it in degrees first last time. It doesn't matter, of course. Did you get 78.69?
Yep.
So you told me, hopefully, that my answers were 78.69 plus or minus 360 n, where n is a whole number. That's all of those angles. And then to find the second one, the one that's all the way around here. So you went to 180 and passed. You added that to 180 and got 258.69. Everybody good with that? No question, you're awesome. Okay, so then you did the same thing in degrees, or you just changed all those to degrees. And you got 1.37 plus or minus 2 pi n. And then to get the one all the way around, you had to add pi to that, right? Just like before we added 180, now we add pi. So you get 4.51. All right, how does everybody feel about that, okay? Everybody good? Okay. All right, that's it for 5.1. I'm so excited. We're ready to start 5.2, which is one of my favorite things to do in the whole wide world. Now, that means our homework will be due. Today is Thursday, so you'll have to send your homework to me because it'll be due Monday. Okay, your homework is due Monday. 5.1. You should have that packet. Gave it to you with the notes. Right? Okay, so you're going to give it your best shot. Let's see. Today is day 2, tomorrow is day 3, so we have office hours tomorrow. So if you look at that homework and you have a question about it, it would be good to come in and we can work through it. Okay? All right. So let's look at 5.2 and see what's going on there. Now, we are doing what is called verifying identities. And that means that you are going to prove it. So you're going to do what essentially is a proof, but it isn't the kind of proof you did in geometry. Instead, what we're going to do is take this thing right here, this equation, and technically there's like a question mark there because we want to know if this is true. And in order to prove whether it's true or not, you pick a side to simplify. Remember the last time we took notes in class, we were doing some simplification problems? So you're going to pretend, and you almost always start with the side that's the hardest. So we're going to start on this side, and we're going to try to simplify it. And in the end, hopefully it will simplify down to sin x. Okay? So get out your colored sheets that we're working on memorizing. We're looking at the first 8 in the first column. Same ones we were looking at the other day. Take a look at what you've got up here and tell me if you notice anything. Isn't that 1? Yes. Sine squared plus cosine squared is 1. So what this says is 1 over cosecant. Wait a minute. That's sine. Because what do we know about cosecant and sine? Aren't they reciprocals? So 1 over one of them is the other one, always. So guess what? You just proved your first identity. You just proved it. That colored sheet is full of identities, but there are millions more. And our job right now is to prove some of these other ones. Now, I don't want you writing this down on your sheet or anything, but this is now an identity. You just proved it. It's true all of the time. All right, let's try number 2. What's your thought on this? You have a thought? Well, kind of think back to the last time we were, taking notes. Sometimes I like to think of this as tangent divided by secant. Is it? And then I know that tangent can be written a couple of ways. What is one really popular way of writing tangent? Sine over cosine. And remember, even though I am saying sine over cosine, I am writing sine x over cosine x, right? You gotta have those x's in there. And then divided by what's secant? 1 over cosine. And then, of course, I am dividing fractions, so I'll multiply by the reciprocal. Are you starting to get excited? What's going to happen? What's going to happen? The cosines are going to cancel. Now, always remember, guys, if this is a plus sign, you can't cancel, right? We cancel when it's a times. But what are we left with? Sine, which is exactly what we wanted to end up with, right? So you just proved your second identity. Good work. Good work. Okay. Number 3. Oh my. Let's see here. Cosine. Cosine tan plus sine of tangent. All right, here we go. Here we go. There is absolutely no rule about which side to work on, but generally speaking, you want to work on the side that's the biggest, because that's going to give you the most things to do and give you most options. So, what do you think might be a plan for cleaning up this mess over here? What would you like to do? There's no wrong answer. I mean, what's something you can do? What? You mean like both sides? Okay, now remember, I don't know that this is true. So I can't do that. I can only work on one side and hopefully end up with that when I'm done. Furthermore, Mr. Kunkel, listen to me. We never divide by a variable. Okay? Okay. All right. Is that a distributive situation? Can I just distribute? Get rid of the parentheses? So cosine tangent plus cosine sine cotangent. Now, we had a problem that looked kind of like this a minute ago. What else could I do?
Can you change tan? Like, can you change tan to sine over cosine?
Exactly. Kids, look. This is what you want to end up with, right? So what do we want to end up with? Cotangents? Secants? No, we want to end up with sines and cosines. So that cosine is fine. I'll keep him. But that tangent is going to become sine over cosine. The cosine is fine. The sine is fine. But the cotangent is going to become cosine over sine. You do not have to put those things over 1. When I am multiplying a string of things together and I'm hoping to cancel, it helps me to stay organized to put them over 1, but you don't need to do that, of course. All right, these are 2 separate things because they got a plus sign in them. What happens here? The cosines cancel and leave them a sign. what happens here?
The sign cancels.
Signs cancel and leave you with cosine squared. Oh my goodness gracious. Isn't that exactly what we wanted? So when we do our proofs, our verifications, we're doing them vertically, and we're operating on one side, but the other side is just coming along for the ride until the end, when I can show that the two sides equal each other. That's the format that we're going to use when we're verifying these. Wait, Mrs. Ford, am I going to have to do this? Yes. Yes. And you'll love it. It's so fun. All right, let's do the next one. Do you have any ideas about the next one? Now, I'm going to say it again. There is no wrong way to start, but you have to start. You can't just look at it. Oscar?
Turns tangent into sine of the cosine.
I think that sounds like a wonderful idea. So tangent is sine over cosine. And what about secant? 1 over cosine. Oh, hey, look, we have a common denominator. That's great. Because normally I would have to get a common denominator to add my fractions. But I have it, so that's great. Oh, shoot. Shoot, shoot, shoot. This is not so great. Because they don't match, do they? Now, that doesn't mean I'm done. That just means I have more work to do. And now is when you need to get a little bit creative, because up to this point, I've encouraged you to do 2 things. Change it into sines and cosines, like you did here, and then use those identities on your paper. So when you saw sine squared plus cosine squared, you made it 1. Well, that's not going to work now. I mean, there's no identities here, and I've already got sines and cosines. What?
Cancel it out.
Cancel what out?
Cancel sine x plus 1. I mean, not that one, cosine x.
Okay, now remember, this side is untouchable. All my work is over here. So I'm not allowed to do anything with this. Even if I were allowed, that's an equals, not a times, so nothing would cancel anyway. So here's what we're going to do. Hang on to your hats. This is where we got to get creative. I am going to multiply the top and the bottom by cosine. Now, first of all, that's legal. And second of all, before you ask me, how did you know to do that? I want you to look at what you're trying to end up with. This is what we want to end up with. What's in the numerator of it? A cosine. I don't have a cosine in the numerator, so I'm going to put 1 in the numerator. It's legal, and I need it. Now, look at what we have now. We have a cosine times sine plus 1 over cosine squared. Now, squareds are handy because look on your colored sheet, your bottom, okay, in that top 8, the bottom 3 involve the function squared, right? Every single function is squared in one of those 3. You got sine squared, cosine squared, tangent squared, secant squared, cosecant squared, cotangent squared. All right, tell me what cosine squared equals. 1 minus sine squared. If you haven't already written that next to the identity, would you do it? The main identity says this, but if you move the sine squared over, cosine squared is 1 minus sine squared, right? That's the same formula, it's just rearranged. So go ahead and write that on your sheet, because you got to get used to recognizing that any squared function can be rewritten. So now I have cosine over sine plus 1 over 1 minus sine squared. Cosine squared is 1 minus sine squared. That's what I just told you to write down. When you weren't listening, I said write this down next to that identity. Every time you have a function squared, it can be rewritten using one of those little formulas. Now, tell me about that denominator. There's no canceling that can happen.
Square root.
This is the difference of squares. It factors. This factors. How does that denominator factor? 1 plus sine and 1 minus sine. That's exactly right. So there's my numerator. Here's my denominator. Now what do you notice? Now you can cancel. Kids, when pluses and minuses are involved, you cannot cancel unless you can cancel the entire quantity. So you can't cancel a piece, but you can cancel a whole. And look at what we're left with. Exactly what we wanted, right?
Will there ever be a problem where it won't work?
Oh, there are lots of problems where it won't work. I will never give you one deliberately. Now, if I miscopy something or write something wrong, it's possible. But I wouldn't do that to you, no. So your assumption is that they're going to work. All right, so I want to go back through this one. This is a little bit more sophisticated than the other ones we did, so I want to go back through it. Step 1 was easy. Remember, you are going to have to reproduce one or do one of these. It'll be a brand new problem you've never seen before, and you got to jump in and do it. You got to do something. You get no points for nothing. So first thing was pretty obvious. Let's change into sines and cosines, right? That's pretty obvious. Second, I kind of messed it up here, but the second thing we did was add these fractions. Now, normally, you need to get a common denominator. We didn't have to this time, but that would be your next step, add them together. Now, the next step was tricky. I stuck that cosine in there. What motivation did I have to stick in a cosine? Why didn't I stick in a sine or something? Because I know this is what I wanted to end up with, right? So I wanted to put a cosine into the numerator so that I had at least part of what I wanted. Now, as soon as I did that, I had a cosine squared, right? Haley, you okay? Yeah. Okay. Now, cosine squared, but I really wanted a sine down there. This is what I wanted to have in my denominator. So remember, this is important. I'll say it again. Anytime you have a function squared, tangent squared, secant squared, cotangent squared, anything squared, you can rewrite it using one of those 3 Pythagorean identities. You can rewrite it. So we rewrote cosine squared as 1 minus sine squared. Then my algebra had to kick in. I had to recognize that was factorable. And then I canceled and I was done. Okay? I promise you'll get better, but I promise it takes practice. You're going to have to practice. So I don't know if you noticed or not, but I just gave you a whole bunch of practice problems. All right, let's try. We've got a couple more here. Let's see what we've got. All right, so let's take a look at number 5. have a plan, an idea, any kind of thought at all?
Make that top one secant minus one.
Make the top one secant squared minus 1. Now, very good, Jesus. He says, look, I have a formula on my sheet, an identity, that says 1 plus tangent squared is secant squared. My teacher just told me that every time I have a squared function, I can rewrite it if I want to. I want to rewrite this because when I rewrite it, it's going to be more secants, so it's going to match the denominator, right? So like he said, tangent squared by itself would be secant squared minus 1. Exactly. Yes, yes. At this point, don't you dare cancel. Remember, you can't cancel when there's adds and subtracts unless the whole shebang goes, and it can't. They're not the same. So instead, you're going to notice you've got the difference of squares up there. So that's secant minus 1, secant plus 1, in either order. Remember, that doesn't matter. Over secant plus 1. And this is staying the same. We're trying to end up with that. What happens? Now we can cancel the whole shebang, right? After you factor, you can cancel it usually. So now we have secant minus 1. That's all that's left. And that's supposed to equal 1 minus cosine over cosine. So I got to change this, hopefully to equal this. Okay, these are cosines, right? So maybe I ought to change my secant into 1 over cosine. And now I have a fraction in the subtraction problem. So I probably need to get a common denominator. And my common denominator will just be cosine. So my denominator is cosine. And my numerator is 1 minus cosine. Yay, you did it, you did it, you did it. Aren't they getting easier? Did I do anything there that confused you? You have a question about it? Mrs. Ford, how did you do this?
I don't understand how you got from like the 1 minus cosine.
Well, it's 1 over cosine minus cosine over cosine. So I just get a common denominator. My common denominator is cosine, so I can combine the numerators. Okay, one more, I think, in this section. We're not going to make our 5-2 homework due just yet because we got to practice this a little bit more. Although, if you tackle it and do it, certainly go ahead and send it to me. We've got sine over 1 minus cosine plus 1 plus cosine over sine equal to 1 plus cosine over sine. Oh my goodness. Oh my goodness. So first of all, make sure I copied it correctly. Years ago, when we had school every day, you know, and I got to see my kids a lot, got to practice a lot, and I was teaching honors at the time, and I loved doing these. So I told the kids I'd give them extra credit if they could come up with an identity that stumped me. And so this kid brought me this identity, and I worked on it and worked on it and worked on it. Couldn't get it to work, and so I said to him, now are you sure this verifies. You've done it, you know it verifies. Oh yeah, Miss Ford, it works, it works. So, spent on, and I couldn't get it, I mean, not hours. I'm not talking about like I sat down for 15 minutes. I spent hours on this thing, cause no kid's gonna stump me, right? So, so I just spent a tremendous amount of time on it. And finally, I mean, after like 2 weeks of doing this every single day, I said, okay, you win. I can't show me how it's done. He had a mistake in like his third step, so it didn't verify. Oh, I was so mad at that kid anyway. All right. Huh?
Did he get the extra credit?
No, he didn't give me a verifiable identity. It was one that doesn't verify. Obviously, you don't just, like if somebody said, give me another practice problem, you don't just make these up. Obviously, you have to plan them and work through them. So anyhow, somebody's planned and worked through this. Tell me what you want to do. So we want to add these two fractions together. So we're going to need to get a common denominator. So this one is going to have a sign. And this one is going to have a 1 minus cosine. Now they have the same denominator, so I'm going to go ahead and write down the denominator. It's 1 minus cosine times sine. That's my denominator. Okay, so what's on top? Well, that piece will just be sine squared, right? Plus, okay, I'm going to go ahead and FOIL this out. Does anybody know what that'll be when I FOIL it? 1 minus cosine squared. All right, now what? That is definitely difference of squares, but wouldn't that bring me right back to where I was up here? So definitely that wouldn't be a wrong thing. It's not like it's incorrect, but it wouldn't make progress. It would like reverse me. So I don't think I want to do that.
Well, you could change the sign. Why don't you get to 1 minus cosine 3 so you can take the cosine out of the denominator?
What now?
You do 1 minus cosine. You take it out. And 1 plus cosine 3.
Okay, but remember, if I do that, I'm going to have that fact. It's like if you have x squared plus yz over z, let's say xz. Nothing cancels in that problem, because in order to cancel when you have a bunch of stuff, you have to be able to cancel out of everything. So while I could, up here, I had that factored out, and I can cancel these out, but that would take me back to the original problem. You're not going to cancel in that problem. Kids, what's 1 minus cosine squared? Sine squared. I know you're fixated on factoring, and that's okay, but you only want to factor if it takes you somewhere. And it won't in this case. I'm going to go ahead and make that sine squared. So now I have 2 sine squared over 1 minus cosine sine. And you know what? I don't like that. And the reason I don't like it is because I really want to keep my cosines in the numerator, don't I? Okay, so I'm going to backtrack. I don't like that plan. It's a good plan, but I don't like it. Instead, I think I'm going to change this guy. What's he? What's sine squared? Oh, so what if I have 1 minus cosine squared plus 1 minus cosine squared over 1 minus cosine sine? so the numerator would be 2 minus 2 cosine squared over 1 minus cosine sine. Because I have 2 and I have 2 of those. Okay, that looks good. What can I do with that?
Take out 2.
Take out a 2. This is getting messy. I'm kind of going all over the place. So that'll be 1 minus cosine squared. I heard somebody say I got it. What am I going to do with 1 minus cosine squared? Oh, no, we can't square root it. That's not an option. You don't have an equation, so you can't square root. Not an option. I'm going to factor it. How does that factor? 1 minus cosine, 1 plus cosine? And what's going to happen now? Now that I factored, I can cancel. And when I cancel these out, what am I left with? What I want, yep. 2 times 1 plus cosine. Now, guys, did you see how I changed course midway through the problem? I had an idea, but after I got it down on paper and started looking at it, it didn't seem right. That's okay. You're using pencil, you can erase it if you want, or just cross it out and continue on. But you're going to take some wrong turns, and it's perfectly okay. Okay? All right, well, we've got a few more minutes. I want to stop in the notes right there. We have a few more minutes, so I want you to take a look at the sheet I just gave you, which for those of you online, it's in extra practice review. It says verify the following. And it actually continues on to the next page. So I've given you 30 extra practice problems. So what I want you to do right now is just look through the sheet, pick one, and let's see if we can do it. All right, so of the 30 on that extra practice sheet, what looks good? 16. All right, let's try 16. All right, so you tell me what occurs to you when you look at problem 16, which looks like this. Oh my gosh, it's supposed to all cancel out and give you 0. All right, well, let's see. What occurs to you? Exactly, squared, make sure they're squared. But Grace hit it on the head. Look, guys, first of all, everything has to cancel out and give you 0. For things to cancel out and give you 0, normally they have to be like terms, right? So that's a cosecant, that's a cosecant, that's a cotangent. He's the oddball. He happens to be squared. And there happens to be an identity that says 1 plus cotangent squared is cosecant squared. It's on your sheet. So cotangent squared, bring the 1 over, would be cosecant squared minus 1. So I'm going to rewrite that as cosecant squared minus 1. Now tell me about cosecant squared minus 1. What about that? It's the difference of squares. All these things, when you start doing them, are going to end up being the difference of squares. So that's the cosecant plus 1, the cosecant minus 1. What happens now? Now we can cancel, because the whole shebang cancels. I never cancel pieces of it, not if there's adds and subtracts. So what am I left with? Cosecant A minus 1 plus 1 minus cosecant A? 0. Good job. One more. And then I promise I'll shut up. One more. Let's try 6 because we haven't had any yet with different variables. So let's try number 6. The variables matter when you start putting them together. You can't put together things that don't match. So we have sine A over cosine A times cosecant B over secant B. Now notice I split my fraction. Is that okay? If I put them together, would I get what's on the sheet? Yes. So I split them to keep the A's together and the B's together. Well, what's that? Isn't that tangent A? So that part's done. Now what about this? Do you have any ideas on how to handle that? Well, can I guess I'll put it in parentheses, but can I think of that as cosecant B divided by secant B? Can I think of it that way? And so then it would be 1 over sine divided by 1 over cosine, and then I'll flip it. And that's going to leave me with 1 over sine times cosine over 1, which when I multiply those, I'm going to get cosine over sine, which is cotangent. So no big deal that there's 2 variables. Just remember, you can't combine a cosine A and a cosecant B, for example. Like variables have to be kept together. Okay? What a great way to end your day. Awesome, awesome work. All right, you guys need to stay on for the blessing. So 5-2 homework I'm not assigning just yet, but if you want to give it a shot, if you can do it, that's great, you can get it done. We're going to spend a little more time practicing. We're not memorizing the whole sheet. What are we memorizing right now? The first 8, that's right, those are manageable. You've been using them. Alright, so I got his.
Get something done tonight since we don't got school tomorrow. I'm down. I got work, but.